Hello, I'm María Jesús Lobo, and I will be presenting FlexER, a platform to evaluate interaction techniques for immersive visualization. This is a work done jointly with Christophe Horter and Paul Irani. Extended reality is an emerging field that groups augmented reality, mixed reality, and virtual reality. The hardware required for extended reality is now affordable, such as VR head-mounted displays, head-mounted augmented reality devices, or mobile phones, and use powerful processors that can render high-resolution images at high frame rates. Immersive analytics use extended reality to visualize data. Recent applications include trajectory, network, and geographic visualization. There are multiple studies that compare interaction techniques, visualizations, or devices for immersive analytics. However, these studies are often tied to a specific hardware or software setup. Thus, they are hard to replicate. So, it remains a challenge to evaluate the capabilities of different platforms for different visualizations and tasks. It is difficult for a designer to choose which tool to use, as no clear design guidelines exist yet. We introduce FlexER, an environment to help design, sharing, and conducting user studies for immersive analytics, based on abstract, low-level tasks. Here we see FlexER. FlexER is based on a JSON specification and provides a user interface to edit the JSON, preview the visualization, and test the different conditions on different devices. The FlexER specification is divided in 6 components to enable reusing them and facilitate sharing and replicating studies. These components are the data, the visualization of the data, the devices, and the corresponding inputs, and the interaction and tasks that are defined using 2 state machines. Each state machine receives the signals coming from the inputs and uses action to trigger transitions between states. Specific visualizations can also be defined for each state. The task state machine also contains the definition of the measures to evaluate user performance, such as time spent in a task or number of errors. Here we have a brushing example. The user can directly edit the JSON and preview the visualization and the participant position. Here, the researcher is comparing 3 devices for this task: a virtual reality headset, a HoloLens, and a tablet. Here we have the final rendering with virtual reality. We use an abstract task to simulate brushing in a scatterplot, where the user has to select a target sphere each time. Here he uses the virtual reality controller to point and select. Here is the rendering with the HoloLens. Here he points with the gaze and selects with the air-pinch HoloLens gesture. And finally, here we have the rendering using the iPad. He points with a ray coming from the screen center and selects with a screen tap. We will show now how FlexER can support debugging the experimental conditions. In this case, we simulate a linking task. We consider that the user goes from one source view to one target view to relate elements. So he first selects an element in the right scatterplot, and then the corresponding element in the left scatterplot will be highlighted so that he can select it. FlexER also provides a visualizations of both state machines to help users debug their interactions and tasks. Here we have the state machines for the linking task. The interaction state machine has only one state to handle selection. And the task state machine has 2 states to handle both selections, one in the source view that triggers the start of the trial, and one in the target view that ends the trial and checks if the answer is correct. While testing the conditions, the researcher can see the participants' result as they perform the trial. Here we have 2 measures: time selecting, that corresponds to the time that participants take to select their target, and the error count, that stores the number of incorrect selections. Here we can see that even if they should, the measures are not being recorded at the same time. So, to understand what is happening, the researcher comes back to the designer user interface and uses the Debug tab to check the state machines. Once she selects an element in the state machine, the corresponding code will be highlighted in the JSON specification. She notices that the measures are not attached to the same state. By clicking on the measure, she can correct the mistake, and the task will work as expected. We conducted user evaluations through remote interviews using the walkthrough approach, with 6 experts working on immersive visualizations, 4 researchers and 2 research engineers. Their feedback was overall positive. They appreciated the component-based approach. However, they had some suggestions for improvement. For example, they mentioned that understanding the JSON specification might be difficult, so adding more visual cues to navigate it would be helpful. They also mentioned that importing 3D objects, for example to simulate an existing room that we cannot access, might be helpful. Finally, one of them mentioned that replaying conditions might be useful to analyze participants' behavior. However, our approach presents several limitations. First, the evaluation only considered 6 participants, and it was done using a walkthrough. Further evaluations with the participants using the system themselves might give us more insight. Second, we use only one state machine for the interaction and for the task, to make the system simpler, but this means we cannot handle complex interactions. Finally, FlexCR was built for abstract tasks and simple visualizations, so it does not scale yet to a big number of objects. More advanced rendering techniques could be used in the future to alleviate this problem. We presented FlexER, a platform to design and conduct user studies comparing devices, visualizations, or interaction techniques for immersive analytics. We hope that FlexER will ease sharing and replicating those studies.